Testing. No problem to get you started, get your brain flowing, because it's related to what we're doing today.
I looked at the homework instead. Yeah.
We can spend a couple minutes trying to wrap this real quick. We'll put it together. Here tried to do some of the homework this weekend for the section. Oh, not enough. I saw several hands go up, but I was hoping to see like 90% of hands go up. I get, today's gonna be rough. Not for me. If you didn't try the homework, this is gonna be banging like a bitch to understand, because it's depending on you understanding what we did last time. And if you understood it without doing the homework, that's fine, but like remembering it and understanding it. There's a difference. How did we go about grabbing this?
Well, the two in front of the cosine, that's the note that our rate where we're gonna start on the wax.
This one is affecting our up and down, right? This affects our affects amplitude. What about the pi over two? What?
Superior,
It's related to our
well,
period,
solved by 2 pi over pi over 2.
divided by pi over two. So this got all tricky, because now we got a fraction and a fraction, right? And remember, we were doing 2 pi over b. And that's b.
Like that.
What?
Why did we do it like that?
Because that's how it breaks up the period, it'll help you find the period. That's our period. So to deal with that, I'm gonna multiply by 2 over pi on top and bottom. Effectively, this equals 1, I'm multiplying by 1, I got the same thing on top and bottom. But by doing that, it allows me to cancel out everything on bottom, leaving 1 on bottom. Here, this ends up being 2 pi over 1 times 2 over pi. The pi's will cancel and I get a period of 4. And since we're breaking up our graph into 4 sections. What does that make each step along the x-axis? 1, 2, 3, 4, right?
Yeah.
We're dividing it by 4. So rather than having increments. Fuck, I didn't get my line on that, there we go. Instead of having pi and 2 pi. The pi got negated by this thing and it's just 1, 2, 3, and 4. And we're going up and down 1 and 2. Well, maybe I should keep it to scale. Does cosine start off high or low or middle? High. So. Our top one was high, our middle one is low, and our end one is high again. And the ones at the quarter marks are at midpoint. And it would keep going through a wave like this. So dividing by a b that has a pi in it kind of. Well, it's a tricky operation when you're doing it, but it actually makes graphing it easier. You can just graph it on the regular little x and y. And not have to worry about what the hell pi is.
So for that, right there, just find the space on the x values. You divide it by 1/2.
I divided, the period, these periods should be broken up into 4 equal parts.
Right. Mark for the. For the
So-
ones on the x on the x.
Period over 4. 4 over 4 equals 1. Tells me how often to make every increment.
Okay, that's the. Is that like the formula to find the points of the.
Yeah, earlier we did with 2 pi over 2b.
Okay.
Right? But that just gave us our like little increment points, but the pi is fucking it up. So it's easier to treat this as divided by 4. Because it does break it up into 4 parts. What if it was y equals negative 2 cosine pi over 2x?
But it was X,
What?
it's a reflection.
It
of
was
what
negative, and we'll start from the bottom right.
Upside down.
It's upside down, is that what you meant?
Yeah,
It's a
yeah,
reflection.
that's.
A reflection across x, yeah. So it starts on the bottom and goes up. We're giving you a minute to finish writing it down. Then I'm gonna shift to doing a graph of y equals x squared because it's gonna easily show what I wanna show you, that's gonna translate all the trig functions. Which is pretty nice.
So like 2 pi is like 6.28, is that like relative to the 4?
Yes, the
That's all you-
6.28 is relative to the 4.
So it'd be a little bit more, would be.
If we went up to 5, then 6, and then 6.28, that'd be 2 pi. Alright, so quick reminder. We had y equals x squared. Y equals x squared is this graph right here. Forever. Y equals. X minus 5 squared like that. Minus 2 looks like this. Each point has been shifted. 5, -2. Five, -2. If I graph better. it would look a little bit more like it. And so if I did a general formula for a parabola. We do x minus h squared plus k. Where the graph changes directions, the bottom of the cup is called the vertex. The vertex is at the point HK. So. Whatever. Is shown in the parentheses here. Affects left or right. But it feels like it switches. X minus 5, we had x minus 5. Minus 5 makes me think left. But we're really gonna move right. This happens across all of the functions that you learn in algebra. If someone took the time to show it to you like this, broken down like this. It works with x cubed, it works with e to the x, it's gonna work today with sine and cosine, and all of our functions are gonna be affected like this. This moves up and down. Or down, I should say. The amount indicated. With the same sign. So we had +2, we're gonna go up 2. If I had -2, we go down 2. Let's apply that to sine and cosine. Fix all of our points. 5 starting points. Right H. Up K. Thank you. X plus H would shift left H. And minus K would shift down K. And I'm gonna put the A in front of it for now. Having the B inside changes stuff a little bit, so I just wanna do it with something like this. First. Y equals 2 cosine. X minus pi over 4. Plus 1. Now, my pro tip to doing this. Pro tip to graph. We have y equals a sine. B. I'm gonna say x minus h right now, like that. Or a cosine b x minus h plus k. Step 1. Graph or plot the 5 points for a sine bx or a cosine bx, whichever one you're looking at. Not the whole curve, just the 5 points. Then 2. Shift your graph. HK.
That's why they did it. That's why you gotta be part of it. That help.
3-part inequality, what?
Yes, that's why they find your. Then you gotta break it up.
No. Yeah, we're gonna do the 4 parts, but like, right now, on this one, I don't have anything in front of it. So my period is just a standard 2 pi. So like, let's take a look at this example first real quick. So y equals 2 cosine. Of x minus pi over 4 plus 1. I'm gonna plot. Y equals 2 cosine x. Then shift. So cosine, we said, started up high and is gonna do this. Those would be, I did this in red, y equals 2 cosine x. Now pi over 4 is 1/2. Of pi over 2. Which means pi over 4 is half the distance. To pi over 2. So this shifts this point right pi over 4. And up 1. In fact, pi over 4 is gonna be the midpoint between each of these. Each one is a pi over 4. So our next point goes pi over 4. Up 1. This one goes pi over 4. Up 1. This one goes right pi over 4. Up 1. And this one goes right pi over 4. Up 1. I'll do the inequality version, the 3-part inequality. I'll show you that in a second. Because some people will like it better. Now that I've got these 5 points, I connect those 5. So if I move pi over 4 right here, going over that much. This one is 2 pi plus pi over 4, that's like 9 pi over 4 right there. So like my first curve is going from pi over 4 to 9 pi over 4. That's one cycle. Where 9 pi over 4 is 2 pi plus pi over 4. Victor was asking about the inequality. We did the 3-part inequality. The base version is 0 is less than or equal to x, which is less than or equal to 2 pi. But this is whatever's in the parentheses. So if we have y equals 2 cosine of x minus pi over 4 plus 1, I could say 0 is less than or equal to x minus pi over 4, which is less than or equal to 2 pi. This is what you are referring to? Okay. And now I want to get x by itself like I have it up here. To do that, I would have to add pi over 4 here. And if I add pi over 4 here, I gotta add it everywhere. And I get pi over 4 is less than or equal to x, which is less than or equal to 9 pi over 4. That shows you the start and the stop. You still have to break this up into 4 equal points. In this case, it's not too bad because the bottom is in terms of 4. So I just gotta go figure out like how far apart the top is. Bottom is in 4. The top goes from pi to 9 pi. So if I do 9 pi minus pi, the difference is 8 pi. So if I divide this in 4. I really don't like this method, but. If you do, this is how you do it. Divide this in 4, we get 2 pi. Our 4 parts. Just keep adding. This. 2 pi to the first value. So we have pi over 4. I add 2 pi on top, I get 3 pi over 4. I add 2 pi on top, I get 5 pi over 4. I add 2 pi on top, I get 7 pi over 4. And I add 2 pi on top, I get 9 pi over 4. Those are. The 5 marks right here. Oh shit. I like doing that method. It makes more sense to you. It's a good way to check to see that you've got the right range. I think it's a hell of a lot harder to graph this way. Personally. Because then we still haven't done the up or down. This is just addressed where the points are, then you've got to adjust for the up or down. I really think it's easier to got the base points with the original model and shift H and K. But if you do it this way on the test, I ain't gonna knock you for it. I'm just gonna think you're batshit crazy. No, ain't nothing wrong with that. Got plenty of batshit crazy in me. I'll let that sink in for a while. I'll put up another question and let you guys run with it. If you can figure that one out, and we'll do it together in like 5 minutes. surprised me as class, I got the test graded, went in over break time, if you come up and tell me your last name, I'll give you back your test. Tell me your first name, I'm not gonna remember your last name, and they're alphabetical by last name, so. Or tell me both. But like, I put that little line on the front. Robert had paid his favorite teacher, and over half of you did. Not a lot over half, but like, over half. Most people don't read the instructions. I was surprised. I don't think Lewis did. I don't think David did either. Did Victor? Gerardo did.
I did.
He did.
Shit.
Yes,
You could also put the -1 in front of, what was that? I think on the book it said, it was C plus or whatever,
yeah, these are the same thing.
that's what slowed me down, because I was used to seeing it the other way,
Really, does the book do it like with the,
yeah.
Huh.
It put C up front,
that's weird.
it goes C, A, B, and D.
It's saying it sounds wrong, it's not alphabetical that way. Read ahead, Victor. You're setting a bad example, now you're gonna add, now you're making the other students look bad.
Victor.
So what would be if I got rid of the shift, what would this look like? What's the equation? I'm looking at 1/2 sine x, not paying attention to shifts. So if I plot that. And since I'm gonna do myself a favor right now. Since I can see there's a 3 pi/4, I'm gonna make sure I've got like. Between 0 and pi. A total of 4 steps. So like. Each of those, if I have 4 steps, this would be like pi/4. 2 pi/4, which is pi/2. 3 pi/4. So between every pi, I'm gonna break it up into 4 steps. Going left, I should have 4 steps between 0 and -2 pi. Rather than going up 1, I'm only going up 1/2, right? So my base graph, the signs start high, low, or middle? Middle. What direction does it go from there? Goes up. 2 pi/4 is the pi/2, so it should be there that it goes up to. I need halfway down. I can make a little bar there. Halfway down here. Halfway down here. If it helps. Put a very light curve. Penciled in, maybe dash line, real light. Cause it's not our final line. But it might help you see what's going on. What does the plus 3 pi over 4 tell us to do?
Shift left.
Shift left. And the minus 1? Shift down. So each point, I'm gonna shift it left 3 pi over 4, and since I put these in increments of pi over 4. I'll just count over 3 and go down 1, which was all the way down here. I guess I need another little half mark going down. And then this one goes left 3 pi over 4. Down 1, which is right there. This one goes left 3 pi over 4 and down 1, which is right there. That one goes left 3 pi over 4 and down 1, which is right there. Finally, that one goes 3 pi over 4 left and down 1, which is right there. And my left side that does spacing doesn't look the same as the right side, does it? Looks a little more scrunched right here than it does over here. And I could go the other way. Let's see. Extend it. Extend it. So sine kind of wiggled around the x-axis. Now it's kind of wiggling around. If I put in the line y equals -1. The sine curve is now waving around that. That's always a helpful check because this -1 is k. Does that make sense? If you did the plotting of the 5 points and did some of the homework for 6.2, this is a hell of a lot easier, because you know where to put the base points. And now all you're doing is moving left or right and then up or down. But we'll look at the catch in a second. Let's do one more of these and then we'll take a break. Okay. Let's do minus. Let's do minus. The 6.2 over or 6.3 over. Waste on Saturday? Yeah, we're gonna 6.2, we're gonna 1, 6.1. Should totally work on this. Well, actually a much straighter forward one than the other ones. Give myself there, so I'm gonna do this. Say that's pi, that's 2 pi. What's the base graph? What's the points for it? What is that? What's the base equation I'm working on?
equals cosine.
Just y equals cosine x. No shifting or anything like that, no up or down change. So high, medium or low to start. Cosine always starts high. So my base points. At pi, it's down at the bottom, and at 2 pi, it's back up at the top. The midpoints, it's there. I'm gonna kind of like lightly draw. Just do a little dotted line. To show what it would look like before we shift it. If I were doing this on my test, I'd probably do it in pencil where I can erase it. Just see, it just helps you keep track of what it should look like. What's going on with each point? So do I go left or right? Who goes with left?
We shoot to the right.
But
Does anyone go with left? What?
I went left, but it's right.
It's right, it's the opposite sign. I tell you, that one, you just gotta remember, it's the opposite of what you wanna do. That's the way I remember it, and I've been dealing with this for fucking ever. And if I don't think about it that way, I always just immediately see negative, and I go left. And it's really easy to get into that habit, but when it's something like this, it's the opposite. So we're not going left, we're going right. Pi over 2 is like halfway between 0 and pi, it's right there. So everything's going over that much. A better spacing here, this would look great. So the green line is y equals cosine of x minus pi over 2. What else is it? What does that graph look like if you didn't see cosine of x minus pi over 2?
Function of sine,
What?
function of sine.
It looks like sine, it's actually just sine without any. It's identical to it. In fact, remember when I was saying you're never gonna use this shit, the whole theta minus 90 degrees kind of thing? It was way back in like chapter, I don't know, 5. Something, it has to do with how. Theta minus 90 was the same thing as. Or cosine of theta minus 90 was the same thing as sine theta. It's taking advantage of those identities. They're weird identities to remember. And I'll be honest, you saw me struck, I wanted to show the graph of sine. Doing this, and I originally wrote plus pi over 2, because I have to stop and think about it. If you get to the point where you don't have to stop and think about it, you're fucking doing better than I am. But like comparing cosine and sine. They are off by just pi over 2, the graph of them. And remembering whether it's a minus pi over 2 or a plus pi over 2 is almost comes down to like sketching it or doing it in your head. Let's take a 10-minute break. If you want your test back, and I hope you do, come on. Let's continue. Let's up our game. Let's say 2x minus pi over 2. Now let's get rid of the 2 in front, let's just deal with that extra. This is the real kicker right here, the real change. When you have something like this, you really want to rewrite this where you factor out the 2. Which means divide or multiply everything on the inside by 1/2. If I did x times 1/2, I'd have x over 2. If I did pi over 2 times 1/2, I'd have pi over 4. Wait, sorry. That would be 2x over 2, shit. Let me rewrite that. Make sure everyone's doing the right thing. Whatever you have on the inside, multiply by 1/2. Which is related to this upside down. And if I do that, I get y equals sine of 2 times x minus pi over 4.
Why are we multiplying it by 1?
Because if I multiply the 2 back in, I'm gonna get the right thing. I'm gonna get what I started with. What I wanna do is factor out 2, factor out b.
You're like trying to get b back down to 1. Turn it back.
Yeah, I'm trying to get this parentheses back down to 1. Where the thing is in front, cause now in this form, this shows me my phase shift. My phase shift is gonna be right pi over 4. Not the pi over 2 we started with. You gotta factor out that number. Now you can always double check to see if you got it right. By multiplying the 2 back in. I'm gonna show it real quick. 2 times x minus pi over 4. If I multiply the 2 back in, I get 2x there. And if I multiply 2 times pi over 4, I get pi over 2. Which is what I started with. So that way you can make sure you factored it out correctly. This just distributing the 2. Distributing b verifies you factored it correctly. Our period now, okay, so this is going to have a phase shift of pi over 4. And now I'm gonna treat this like y equals sine of 2x to find my points. And the idea why. Before I go into do it, why do we factor out the 2? Notice I have 2 times x minus pi over 4. If I plug in x equals 2, or I'm sorry, plug in x equals pi over 4. I have sine of 2 times pi over 4 minus pi over 4. Which is sine of 0. And that's a base point. And if I don't factor out the two. If I don't factor it out. You might think the point is pi over two. The base 0 point. Is x equals pi over two. But if I put pi over two in, I get y equals sine of two times pi over two minus pi over two. Which is sine of pi over two. Which is 1. That's not, sine starts at 0. So like using the default way it's set up. Isn't gonna make graphing very easy. By factoring out the two, you can see exactly where your graph starts at. That's shift. Does that make sense?
Yeah.
There you sir. It smells like roses over here. Fresh baked chocolate chip cookies. Fresh bacon, fried bacon, yeah. It kind of makes you come out of your bedroom and you're out. That sounds good, what's cooking? That's what you're missing. You don't give me the thumbs down. Alright. Let's try graphing this y equals sine of two x minus pi over two. And so to do that, we factor out that two. I tend to like to use a bracket and then parentheses, so that way I don't have two sets of parentheses in a row. I think that's fucking harder to read. This is harder to read than the bracketed version. Personally. But if you do the parentheses on both, that's fine. I'm not, that's just personal preference. So I know my phase shift is positive pi over 4. My B here is 2. So my period is 2 pi over B, which is pi. So I'm, in terms of that interval inequality, the base looks like that. And then we have plus phase shift. So it's pi wide, we need this in 4 parts. So divide that by 4 and you get size of each step. Pi there, 4 there. That's so not a straight fucking line. God damn, that's terrible. That's embarrassing. It helps, label all the ones you want. We had no amplitude change here, so 1 and -1. So we need to do the full wave between 0 and pi, full cycle, 0 to pi. The sign start in the middle or high or low? Middle,
Starts at 0.
starts at 0.
Yeah.
And we're making each step pi over 4. So then high, then middle, then low, then middle. Then high, then middle. Then low, then middle. If I wanted to do it real lightly, I could. We haven't done our phase shift yet, though. So if you do this, do it real light. Like I need to be able to tell the difference on it when like on the test, what your actual graph is and what your test graph or your base graph is. I have a phase shift to pi over 4, is that left or right? It's right. Do I have any vertical shift? Yeah. So every point is just going right, pi over 4. Maybe more than one cycle, I could go back and go the other way. Once you get that. What it should look like, you know, the waves, how far apart they should be. So Victor was asking me a question during break, and I think it's worth pointing out that the way that homework's wanting you to answer it. If A is negative. Like if we had y equals -2 sine x. In the amplitude box. Do the positive version. Put in amplitude is 2. And then there's a little box that says x-axis reflection. That's where you check mark that. That'll do the flip, make it negative. I think he had it in with like the amplitude. I forget how we had it, but like if you put the negative here and don't check this, I'm not certain if it takes it or not. I know it will take this, amplitude should be a positive amount. In general, that's we want amplitude to be a positive amount, and just whether or not it flips it or not, it's. So that's a pro tip for homework. Don't worry, on the actual paper test, you get to graph it all by hand, so you don't need to worry about that shit. In fact, if you wanna make sure while you're doing the homework. Try graphing it by hand before you plug it into the computer. Like, try graphing by hand rather than just like, it'll just prompt you, what's pi, what's the phase shift, what's the amplitude? Try graphing it by hand, and then when you plug in the answers in the computer, see if your graph matches what the computer has. That way you'll know you're more prepared for the test. Right, makes sense? You guys ready to kick this up? Let's go the full throttle. Does anyone need a longer? Yeah. Couple people still right, let me pause. For those that want to continue on, I will set you up for the. I hate you, Mr. Jones problem. Don't hate me yet. No. Well, you will. Doesn't get a whole lot harder than this. And this is a low stakes environment, you're not getting tested on, I'm not even gonna look at your work.
Actually, since we don't know the problems again.
Shit, it's way too early, I gotta teach till 7, it's too early for that. Fuck. This dumbass, this is the dumbass your teacher is. He really wanted to teach Calc 3, which is at 8 AM, and so Monday through Thursday, every single day. So grabbed it first, and then he goes. There's a lot of Tulare classes, someone needs to cover the evening ones, let me go do those. 7 o'clock doesn't seem too late. 7 o'clock's not too late if you don't have to fucking get up and be at work at 8 o'clock in the morning in Visalia, and you live in Tulare. This like really like hampers the free time in the evening now. Calculus is done at 9, so I'm like home by 9:30 and I don't have to get over here till 2:30. So I have like 5 hours during the day to get shit done, like if I need to go to the doctors or shit like that. But still, it makes it a long day. Sure, people are starting with the right one. What do I need to do first?
Figure out why equals negative. Yeah.
Yeah, we're gonna do 3x, so that's, we're gonna find the base points. y equals -2 cosine 3x. What kind of phase shift and shit am I gonna have?
Base of 3, 5.
Pi over 3. So if I pull out the 3. I'm effectively dividing everything here by 3 when I pull it out. And that's gonna leave x for the first part and pi over 3 for the second part. So we'll have a phase shift. Is it left or right?
And this one we can
Right.
do-
Gonna be to the right, pi over 3. And we have a vertical shift, is it up or down? It's up. This is a real pain in the ass. Pi over 3 is gonna make it so like your units aren't very friendly. Well, they might be, you factored out the 3. It's the period. Pi over 3. If I wanna see my step size. Multiply that by 1/4. And I wouldn't reduce it. You get 2 pi over 12. For what?
if we will.
It's 2 pi divided by b and that's b. I can, but like, I don't know if you do, it's gonna make it harder to graph. Cause we need to go in 4 step sizes. What is 2 pi over 3 times with the base of 4? Maybe I do, maybe I want to, this is going up to 8 pi over 12. So I'm gonna have 2 pi over 12. 4 pi over 12. 6 pi over 12. 8 pi over 12. If I simplify, what do I get? I would get pi over 6. This is pi over 3. And now this gets kind of ugly. Because I'm having different denominators if I simplify. I also need to phase shift pi over 3. What is a pi over 3 phase shift with a denominator of 12? I want to end up with the 12 on bottom, what do I need to have? 4 pi. So if I do my stuff in increments of 12 on bottom. I can figure out, like, counting over 4 is easier. I do, which way is this fucking going? Up 5 total. I'm gonna do this, I'm gonna make 12 little steps here. 1, 2, 3, 4, 5, 6. This will be 6 pi/12. That's 3 pi/12. Pi/12. 7, 8, 9, 10, 11, 12. 12 pi/12. And that one would be 9 pi/12. These are the ones our base points are at. So 2 pi/12 is here. Does -2 cosine start off at high, medium, or low? Starts at a low. Cosine's normally high, but the negative is gonna flip it. So we're gonna go to 2 pi/2 and we're gonna go down 2. And we saw our step size is 2 pi/12, so every 2 right we go, we'll shift it. So we got low, middle. High. Middle. The hell? Fuck am I doing? Right, I feel like putting in a phase shift that's not there.
Tell you what I want to draw.
I'm like, this isn't fucking right.
That's not including the vertical. shift, right?
Yeah, I haven't done any shifts yet. There we go.
We're gonna check the box.
I started shifting the shit. I saw the 2 pi/12 and that threw me off. Really, the first one is 0. 2 pi/12. Alright, those are my base ones. Now we're doing our little shift. Well, I don't know if it's little. It does, the -2 has already been accounted for. We don't need to worry about it no more. So we are gonna go right 4 pi/12. And we're gonna go up 3. So every one of these dashes is a pi/12, so 1, 2, 3, 4. And then up 3 is right there. And this right one is 1, 2, 3, 4. Up 3 is right there. This one is 1, 2, 3, 4. Up 3 is up here. One, 2, 3, 4. Up 3 is right there. And this one, 1, 2, 3, 4. Up 3 is right here. And then it's gonna oscillate or repeating wave. This is why you wanna do that base one in pencil. Like this looks like shit with my little red X's on there.
So that's your,
The final version is the green graph.
your shift to your horizontal shift plus. Pi/3.
Pi/3, but pi/3 is the same thing as 4 pi/12. The key, you gotta get them in the same denominator to figure out which one. If you're doing like things like this, you don't wanna kinda go like, I don't. If I just had everything in terms of. Pi/12 and I just try to do pi/3. Without like figuring out what the fraction version is in 12, so I'm guessing where I'm putting that movement. And that doesn't help you any. If you get everything in the same denominator, everything gets a lot easier. Do I have a period of 2 pi/3? Right now, it's starting at 4 pi/12. And it ends at 12 pi/12. So if we do that difference thing where we subtract the top. 12 pi minus 4 pi. Is 8 pi/12. And if you reduce, you do get 2 pi/3. There's just a lot of shit to keep track of, there really is, this takes practice. This, I told you it wasn't gonna be easy. You guys want another, or you guys? If you're good, you can go, if you want another, I'll put another one up. You're just making shit up. If I factor out the pi/2. Wanna take whatever that's there and divide by what you factored out. And. Multiply both of them by the bottom upside down. Looks like a 1/2, right? That gonna suck? I don't know. What's the period look like? Two pi over b is 2 pi/pi/2, we're doing that same thing. It's like 4. So 1/2 isn't too bad. I wanna do the base evenly spaced out 4 steps. Step size is 4 times 1/4. So we'll be at 0, 1, 2, 3, and 4.
So is that times 1/4? That's just a universal every time, you take whatever you've got, times it by a quarter.
If you're trying to break something into 4 equal parts, yes.
Okay.
Times 1/4 is the same thing as divided by 4, and if you're dividing something up in 4 equal parts. Whatever number of equal parts you're doing, you divide by that number. Pizzas are often divided up into 8 equal parts, so you do divide by 8 or times 1/8. Base points. Do I start high, middle, or low? Yeah, middle. Am I going high, middle, or high or low for the next part?
No.
Yeah, we're gonna go downward, and we're only going down 1/2, not a full 1. So my base points would look like that. What does my left or right shift look like? 1/2, but is it left or right? It's gonna be right 1/2. Am I going up or down? And by how much?
Yeah.
Down 1. So right 1/2. Looks like I need another halfway mark right there. Right 1/2, down 1. Right 1/2, down 1. Right 1/2, down 1. Right 1/2, down 1. And right 1/2, down 1. The sign should have 3 in a row. Horizontally. So if I graph this. Bang. I strongly recommend you try some of these problems before Thursday. Even if it's only a couple, because secant and cosecant. Y equals just where we're going, y equals secant x, this is like doing y equals 1 over cosine x. And y equals cosecant x. Is y equals 1 over sine x. So the graph of cosine x and sine x very much affect what cosecant and secant look like. So knowing how these are graphed are essential for that. We're also doing tangent and cotangent, but they're their own thing. They're like Elmo on Sesame Street, no other Sesame Street character. I don't know. Mentally deficient as Elmo, is that a polite way of saying it?
What is Elmo? Okay.
I don't know what he is, but he is not, he's dumb as rocks.
Not a dog.
He refers to himself always in the third person, which is like, no. Alright, I'll see you guys on Thursday. Don't do anything I wouldn't do.